just so I get a better idea. How many people here use virtualization of some shape or form? How many people are using a cloud of some shape or form? OpenStack? CloudStack? Better get your hand up there, kiddo. KVM users? Xen users? VMware users? Yes, we love you too. You're allowed to stay. Hyper-V? Oh, I see real hesitation. The other ones, you know, it's like, okay, well, Hyper-V, This slide deck, by the way, is already up on xenproject.org. So if you're, you know, looking for it, there's a slightly earlier version that they gave to the show a few days ago. I don't know if it's up on the website or not, but this particular deck, the one with the revisions, is already on xenproject.org, and I will give a copy to the Scale folks. But it's out there now, so. I have a watch somewhere. I should put that on. How many people was this your first Scale? Show of hands. What you think? First timers? Overwhelming. In a good way, I hope. Okay, cool. Other comments from first timers? You coming back? Coming back? You know, I do a lot of conference speaking during the course of the year, and this is really one of my absolute favorites. Because it's not fancy, it's not glitzy, it's not corporate, but it's got a ton and a half of heart and lots of good information and good people. So, and no snow, except for the virtual snow, which you were provided at no extra cost. Yeah, and this is always a great show, always a great show. How many people live out of state? Show of hands. Everyone's Californian? My gosh. Yeah, well, so I also, you know, you'd be surprised who shows up. You'd be surprised who shows up at the Texas Linux X or Linux Fest Northwest or Southeast Linux Fest. I mean, you know, you get a huge crossover. You really do. Yeah, Southeast Linux Fest had a booth at Scale, and you know, I bet it did them pretty well because in talking with them early on, you know, people move around. It's not like everything's got to be in your backyard. That I know for sure because you know, living in the greater Washington D.C. area, there's a lot of stuff, and nothing is open source. You know, I mean that I can go to or want to go to or what have you. The closest thing to me is actually CPOSC, which is the Central Pennsylvania Open Source Conference. That normally runs about 100 people. You know, if you think this is a volunteer organization, check them out sometime. But, you know, I really do enjoy coming to these places like Scale, like Texas Linux Fest, Linux Fest Northwest, if anyone has ever seen that show. Also very good. It's like one of the biggest little shows you've ever seen in your life. Because it's at a technical college, so most of the rooms are like 40 chairs, but they'll have like 13 tracks going at the same time. So it's just this massive small show, but you know, which is pretty cool in and of itself. We've got about 2 more minutes, and then we can get started. Just a question, how many people came to this conference hoping to learn more about Docker? Show of hands. Now what is it, once again, it's almost like I was asking the Hyper-V question again. We're ashamed, come on, we can get over the shame. How many people wanted to learn something about Docker coming here? Okay, a few people, okay. Just checking. How many people regard yourselves as open source people? It's an interesting question. It's actually been one on my mind. We got a minute, but I started with Linux. I'm just hitting my 20th anniversary with Linux. And so I was around during a lot of the early conferences in the 90s. And then I went with a company that was consuming open source but not producing, and then that got eaten by a company that was allergic to open source. And then I got into the situation where I can actually stand up here and promote open source again. And the thing I noticed is that in the gap, inside those intervening years, sometimes the knowledge of what people went through doesn't quite convey. And so you have people who are working on open source projects who, if that project went away today, would work for a closed source company tomorrow and wouldn't think twice. And that's exceptionally different than the way it was 20 years ago. And I actually do an entire different talk on that at some point. I've done it a few places. But it's a concern of mine that those of us who kind of feel the heartbeat of open source share that, share what the value is with new people as they come along. Okay, it looks like we've hit the start. So thank you all for coming. I know it's Sunday afternoon. It's the next to last unit of the day. You probably have places to be, even if there is no snow. And we're going to talk about the next generation of cloud, the rise of the unikernel, if this works, which it's not. There we go. The obligatory slide about who the heck is the fat geek up front, I won't read it to you. You're capable of doing that on your own. My name is Russ Pavlicek. I am evangelist for Xen Project. Xen Project being the oldest open source hypervisor. We've been around for 12 years now. We power some of the biggest clouds in the industry. As I said before, my passion for open source runs back 20 years. So coming up and being able to stand in front of you all is really a privilege today, and I count it as a privilege. And today I'd like to talk about unikernels. Now, I'm going to say up front, I'm not an expert in unikernels. I am not a unikernel developer. However, part of my job of being an evangelist is to be able to see when something important is happening. And I began to realize that there were lots of these unikernel efforts which have sprung up in the last few years. And people talk about the individual efforts, but not that many people talking about the bigger picture. The fact that these things are occurring and why they're occurring and the power beyond why they're here. So we're going to talk about both the forest and the trees. We're going to talk a little bit about the unikernel movement and what it means to the cloud particularly, but also some of the individual unikernels that are out there right now and things that you can pick up and start to play with or use or what have you. How many people have used a unikernel before? Show of hands. The one man who is actually working with the company that creates one of these unikernels, Don Marty from Cloudia Systems. Hello, Don. Everyone say hello, Don. Okay. Okay, so let's talk just for a couple minutes about the forest. In other words, why do we care about these things? What's the importance of the unikernel? You know, up until now, the world of cloud has been sort of focused on orchestration, right? It's how do we get this cloud to do what we want it to do? What engine do we use? Do we use OpenStack? Do we use CloudStack? Do we use something else? About 10 years ago now, I was with a company that was doing a cloud orchestration thing before the word cloud was ever really coined. We used to call it agile infrastructure. We didn't have a good word for it, you know. So it's been out there. There's been a lot of people trying to solve the problem of how to make things come and go as we want. And that's really been the focus of cloud till now, generally speaking. It's applications with full stacks working inside this orchestrated environment. So we haven't really cared about what these applications look like. They look pretty much the same way they've always looked. So the VMs are kind of beefy, and you got large memory footprint. They just look like they're just running on iron, basically. And so it all works. It's fine that it works, but efficiency is a question. And up until recently, if you could get into double digits of VMs on a single host, it was like, yeah, I got it in, you know. It's not that long ago when, you know, everything was done in single digits. Now we're getting the bigger, beefier machines, but still, you're lucky if you're talking about tens of VMs on a host. Now, what about the next generation cloud? What do I mean by that? I'm saying it's time to take a look at these workloads, at the apps, at the things that are going on in the cloud, and to make them better. They should be easier to manage and deploy. It's part of the reason why, you know, Docker is getting a lot of good press, because it's solving part of that problem and say we can make it so it's easy to get that workload out there. That's part of what we need. Smaller footprint. We've got to get rid of this unnecessary duplication. You know, we want a fast startup. You don't want to have to wait for hardware to initialize that isn't even there, for crying out loud. You want something that's going to hop to it. We also need, in the cloud, higher levels of security. That's, you know, that's been the bugaboo since day one. I'll tell you, having worked inside, you know, as I said, a company that was pioneering in the clouds, that was always a huge part of the sale. Am I going to be secure if I put stuff out in the cloud? It's a big issue. But really the target here, if the laser works and the laser isn't working or doesn't work well enough, ideally we'd like to be talking about thousands of VMs per host someday. We're looking at an entirely different scale. And as I said, the new stuff with Docker makes some steps. It does make that deployment easier. It does make a smaller footprint. That's really good. Less memory, using a shared kernel space, less disk, fast startup times, higher number of VMs per host. All of that is goodness. Those are steps towards that next generation cloud. But there are downsides too. Issues about, you know, you got to share that kernel. Well, you know, what if you have something that can't use that kernel? Well, it doesn't really fit. Potential limits to scalability, you know, how many people are running thousands of processes on their Linux boxes? A few. But it's not, you know, that's not really been the sweet spot for Linux. That really hasn't been the target for these sorts of things. Security, huge, and getting more huge, for crying out loud. Every time we get one of those, you know, reports on the evening news of somebody's been, you know, somebody's information's been hacked into, and suddenly every credit card in the frickin' universe has, you know, been violated. We're aware of these things. Security is a huge issue. And at LinuxCon last year, the Docker CEO was up there, and he was talking about the 5 priorities for his work. Security wasn't even on the top 5. So he's looking at other issues. And we even found at that conference that Google was talking, as well as some other ones, about, you know, using containers. And they said, well, when we need security, we throw a container in a hypervisor. So clearly there is that sort of issue there that still needs to be solved. But there is something else out here which kind of plays in the same area but does some extremely interesting things. And that's called Unikernel, sometimes called exokernels or cloud operating systems. The verbiage is still sort of forming, as are the efforts. These are very small, very efficient, very quick boot times, and we'll see some of that in just a few minutes. And one of the very interesting traits, inherently more secure than the loads you're working now. It's a green technology which saves you green. What do I mean by that? I guess about 10 years ago now, I was working with a customer who had designed and built a new data center. He was moving his racks in. And one day he turned to me and said, you know, this place is full. It's like, what do you mean it's full? You haven't even wired half the place yet. What do you mean it's full? I said, no. I know where every machine is going in this data center. I know where every wire is going to get laid. When I'm done putting everything in, this place will be absolutely full. I can't put another machine in there. Well, why'd you build a data center that's already maxed out? He said, simple. Talk to the power company. This is how much power they could give me, period. Can't get any bigger. If I want more, I got to go somewhere else, build another data center. I'm at my limit. So you look at something like that, and you have an entire data center that's maxed out prior to day one. It's already that way because you need power. If you haven't done, how many people have actually, done ops type stuff or infrastructure management or anything like this in your history? Yeah, it takes power for machines to go on. It takes even more power to cool them down. That's a real concern. So something that could actually work lower power, higher density, this could be tremendous. I mean, if I had back then, if I could tell that man, listen, I could even get you even just 20% savings. We would have had to get a ladder to get him off the roof. I mean, he'd be enthralled. But we didn't have that sort of technology. Unikernels are one way that we may see even more significant savings than that. Many of these unikernels already exist, one of them being Mirage OS. And Mirage OS is inside the Xen Project incubator. Xen Project's part of the Linux Foundation collaborative projects. We have our own incubator with certain projects in there. Mirage is one of them. But there are several unikernels out there, and we will talk about a few of them. So what really is a unikernel? And I'm going to use some of the Mirage stuff as a good basis because there are slightly different concepts, but this is a good baseline. And their definition is unikernels are specialized virtual machine images compiled from the modular stack of application code, system libraries, and configuration. So in other words, these are very small total operating images. They don't actually have an operating system underneath them. They're designed to rest exactly on a hypervisor, period. They're not really dealing with metal. So let's take a look at a few slides here. We see a stack over here that we're kind of familiar with in white. You got configuration files all the way down to the network stack. You have these very many things. The Mirage compiler takes the top part of that and builds a unikernel runtime, which sits, in this case, on top of Unix. And this is during the development phase. So in development, you're actually sitting it on top of a, let's say, Linux-like operating system. The next step is once you get through with development, you want to go into test, the compiler actually compiles the entire stack, all the way through the file system, network stack. All of that becomes part of the image. And all that sits on the Linux-like operating system for testing. When you're satisfied with what's going on there and want to go into deployment, the picture changes again. Once again, we take the entire stack, we compile it, but we put it all in a package that's suitable to run directly on a hypervisor, which sits directly on the metal. It's an entirely different concept. It is basically echoing what is generally done in embedded systems. We'll talk about that in a minute as well. So the concept is you want just enough to do the job. You don't need multiple users, and we'll talk about that in just a moment, usually you just want one user per VM. You want those VMs, however, to come and go quickly and as needed by the function. You don't need a general purpose operating system, you know? Linux, BSDs, whatever your thing of choice. It's heavy. It takes a lot of space, a lot of CPU to keep going. You don't need utilities either. If you don't have an operating system, you don't need bash. You don't need all the utilities that you expect to find and that a hacker might expect to find. You don't need the full set of operating system functions. You only need the functions that you need to get your job done, period, end of discussion. Why build all sorts of capabilities into a VM that doesn't need to do any of that stuff? That's the concept. So it's lean, it's mean, it minimizes waste, and it's got a tiny, tiny footprint, generally speaking. There are some exceptions which we'll talk about, but that's kind of the concept. So this is using some embedded thought, embedded process in a cloud setting. Now, as anyone spend any time doing embedded systems programming here? Okay, a few people. You know, you're not necessarily going to get everything that you want out of that live embedded system, so you have to sort of change your techniques a bit to be able to debug. So you have limited debugging on the deployed system, but instead you have to do different types of analysis and implementation when you're dealing with system failures. But that's part of the trade-off if you want an ultra-light image. And we're going to talk about what does it mean, an ultra-light image? Are we saving a few megabytes, or are we saving something bigger than that? Well, let's take a look at a few instances. Mirage OS has a fully functioning DNS server that is built at 449 kilobytes. Now, some of us with gray hair may have to help some of the younger people in the room to understand what a kilobyte is, because we're used to talking about gigabytes and terabytes and petabytes. A kilobyte is something that we all lived and died with about 20 years ago. Yeah, that's right. It's a magazine. And yet, a fully functional DNS server at less than half a megabyte. A fully functional web server, 674 KB. An OpenFlow learning switch, 0.4 of a megabyte in size. LING is another unikernel, which we'll be talking about in a moment. They talk about boot times of less than 100 milliseconds. We will take a look at one of their websites, which is actually built using unikernels. At the time that I took a look at it, it was using about a little over 8 megabytes to run. ClickOS, another unikernel that's out there from NEC Labs in Europe, has network devices capable of processing over 5 million packets per second. 6 megabytes of memory, 30 millisecond boot times. We're talking about extremes. Oh, and for people who came in late, these slides are out on xenproject.org, so you don't have to like use up your entire SIM card here just trying to get images. It's all out there. XenProject.org is the center of the Xen universe. That's always if you're looking for anything that has to do with Xen, go start there, you'll find it. Now, what about security? Most of these unikernels are written in type-safe languages like Haskell and OCaml and some of these other ones. Not all of them, but a lot of them are. So, I mean, how many people have had to deal with software certification, like inside an airplane fly-by-wire stuff? That's god-awful, ugly stuff to make sure that these critical systems work. And it's not the type of thing that you're going to throw an entire Linux install at, because, if you take all of Warren Buffett's money and, a couple parallel universes, it's still going to take you, beyond our lifetime to get the certification done. It's incredibly hard. But something that's small and type safe, it's possible for certification, which is an interesting concept. The image footprints are now unique to the image. You're not just layering things layer upon layer upon layer in a full operating system structure. Rather, you have a compact image that only has in it the things that are necessary for that image to work. So you don't have utilities to exploit. You can't get to the shell. There is no shell. You can't use grep. You can't use anything. It just doesn't exist. It's not needed. You have just enough to get the job done. So that's kind of the broad picture. That's the forest. Let's talk a little bit about some of the trees in the forest. What's out there right now? These are just a few. Mirage OS, as I said, in the Xen Project incubator. HaLVM from Galois. Galois, in fact, I think just recently was on an episode of 60 Minutes for some of the work that they're doing. A really interesting group of folks. LING from Erlang on Xen. ClickOS, which is networking stuff, which we'll see in a moment. OSV, which Don there so wonderfully represents, from Cloudius Systems. And there's a whole lot more. So let's take a look at Mirage for a second. As I said, it's in the incubator for Xen Project. It is written in OCaml. How many people are here are OCaml heads? Congratulations, you win the prize. That's one more than I thought was going to raise their hand, so that's pretty cool. In fact, one of the guys from Mirage wrote a book this past year on OCaml, and a few of us were, I think it was at OSCON, where it was being unveiled or whatever, and we kind of looked at each other and said, well, let's see, he's got 30 books to give away. If we all go through the line 6 times, we can get rid of all the books for him. But he actually got rid of them. But, you know, OCaml's kind of an odd language, but hey, we like odd languages sometimes. It is built on top of Xen Project. Version 2 was released this past year. It's built for doing general purpose devices. And you can even run Mirage OS in Amazon virtual machines. And you can see Open Mirage there in the link when you get the slides. HaLVM is by Galois. That's in Haskell. How many Haskell programmers floating around? About as many as OCaml programmers, okay? Once again, it's designed to work with Xen. Why would these things be designed to work with Xen, would you think? Anyone have a notion? Amazon friendly? Well, more to the point, Xen is a type 1 hypervisor. That is, it runs directly on metal. So you don't need to have a host operating system. So in other words, you can keep those layers razor thin. And that's part of the design goal of these things. It was, and yes, we will talk about the difference in OSV. OSV is a different animal. You know, originally Galois had HaLVM as a way of prototyping operating system components, but now they're actually using it for network-based devices, which of course is a very popular topic these days. There's a lot of things going on about software virtualization of networks, and HaLVM wants to play very much in that area. And we've got things like LING, which is Erlang on Xen, and it supports Erlang. How many Erlang programmers? Notably the same one who was a Haskell programmer. This is not a coincidence. They have some interesting use cases out on their website, including what they call zero-footprint clouds. And the notion that they put forth is a very interesting notion, and that is that instead of having all of these processes waiting around for something to do, and when the traffic comes in, it responds to the traffic, sends the response, and then sits there and waits again. If you have something that's suitably fast, when the packet comes through, you can start up the process that's going to respond to it. It will respond to the process and then die. So that if you're getting slash-dotted, the moment before you're being slash-dotted, let me make sure that everyone knows what being I mean, I'm old enough that I know what being slash-dotted is. Is this a common term still? Okay. some, yes, some. Basically, if you're getting a flood, okay, you just announced, it's fries and it's the week before Christmas, and you just announced that all TVs are half price, okay? So you're just getting boom, 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 boom. You're getting barraged suddenly. Their use case is, how about we have the processes that arise, respond, and die, so that 1 minute before the barrage starts, you have no VMs floating around out there. A minute after the last packet responds, you have no VMs sitting around out there. They come and go exactly as needed, as quickly as needed. Bing, 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 bing. Interesting concept, and one that is quite suitable in a unikernel environment. Here's a web page. Let me see if we can actually try a live demo at the show, because I just listened to Mr. Marty talk about the importance of live demos, so here's one. And let's just pray that the network holds up. Otherwise, we'll look at the awful slides. So this is the actual Erlang on Xen website. And if I just click up there in the corner, they're going to show us what's under the covers at the moment. And right now, their website is using 12.6 megabytes of memory. And you can see some of these other things that are out there, some interesting data, but it's this ultra lightweight concept. Now they actually have a nice little demo for Zerg. Let's see whether Zerg is here. An instance per demo request. So this is sort of their zero impact cloud done in a demo form. And here's the response. 300 seconds is how long it took. 300 seconds? Okay. Yeah, okay. Thank you. 300 seconds, that's how long it would take to get a Linux instance on Amazon. 50 seconds, the time to get something up on an Android. And 0.2 of a second. That's when they received their request, put together this page, and then died. And the system is this VM that responded to us was long dead when we saw it. So this is part of their overall concept. These fast, nimble, responsive, lightweight images. Let's go back to the slideware for a second. We don't need those. Another one, ClickOS from NEC Europe. They've got language support. I think it's actually written with Python, but they got language support for C and C++ as well. Once again, supports Xen Hypervisor v02, released last year. Network function virtualization is their thrust. For Xen Project, we have annual developer summits, and we get all sorts of interesting things, talks that come up at the developer summit. And the last couple of years, the ClickOS people have been there sharing some of the stuff that they've been doing, and it's been absolutely marvelous to see. Here's some verbiage from their website. Let's let them talk about some of the things they're doing. So we see it's talking about network function virtualization, which is a big issue. Running a Click modular router software. I can't see the highlighting here that I put on it. Down the last line, you see these virtual machines are small, 6 megabytes, boot quickly in about 30 milliseconds, and add a little delay of 45 microseconds. So these are these tiny, tiny things. What sort of throughput? And this is a chart off of their website. And we can see from this, we're talking about the throughputs of in excess of 5 million packets per second coming through on their technology. They've also done some really interesting benchmarking, which they shared with us at Developer Summit, which will help Xen better support multitudes of these sorts of highly performant small VMs. We'll talk about that in just a couple of minutes. OSV, Don's favorite, cloudiest systems, language supports of it's Java, but also C and C++ bindings, correct?
Yes, we just got Ruby.
Oh, and Ruby too. Wow. Now, They have a much wider hypervisor support, not only Xen Project, but KVM, VMware. Do you have any more on there?
Xen, VMware, and VirtualBox.
And VirtualBox, okay.
As far as language support goes, we also have all the other JVM languages. So if you're into Clojure, for example, you're not left out.
Okay, so JVM languages as well. So very wide. They are slightly different in the unikernel world than most of the others, but we like Don anyway. Inside unikernel terms, OSV is kind of fat because they're taking a slightly different tack. Rather, and it has a lot to do with what makes sense with Java. I mean, Java already has this delivery system where you can just sort of drop your little jar file right on top of the environment and you let it go. They said, well, we could use that in a virtual machine environment. So you take that existing jar file minus anything that's multi-processing. So they support threads, but not multi-processing, not multiple processes, not forks. And you just pop it on there, and bing, you're going. I mean, it's a very impressive sort of thing. Now, it takes up more room than some of these other ones that we've seen, but there's lots and lots of applications where this would be a very interesting solution. And you wouldn't have to re-architect for a lot of these things. I mean, you know, literally you can pop a jar in and let it roll. And you have something that is not going to be so easy to penetrate.
So just to sort of restate this for, I guess, case down or whatever, but where you're essentially putting an embedded platform on hardware from what it looks like, right? I mean, the Xen acts as the hardware, you're not putting a full OS, but some type of embedded, and you know, even the fact that this thread, most of them don't, they're procedure that are.
Yeah. For keeping OSV a little bit separate from the others, what you're saying, yeah, basically it's sometimes also called a library operating system. Basically just the functions that are required for the application to live, and that's it. So there is no operating system layer inside the true sense of the word, kind of like you'd see inside the embedded world.
Well, I mean, you might have a very small real-time-ish operating system, or you might run several of these on the same machine, but to serve the same purpose.
Well, inside this world, basically, you don't even have that. You have the scheduling that's done by the hypervisor. So the hypervisor is there giving time to the various VMs, but there isn't any true operating system layer that's present. Now, off of the OSV website, there's a few things that they're talking about here. Network function virtualization, once again, well-suited. Java application server. How many people are dealing with Java applications inside your environment? C and C+ based applications. You know, there is a lot of interesting possibilities on both sides. And you say, well, wait a sec, this doesn't quite fit the same description as some of the others. Well, you know what? The unikernel world is not, it's not like it's a language. It's an area of more and more exploration. So there's room for people to play with the concept and come up with a concept that works. And we see that this has lots and lots of potential to it because there's lots and lots of applications that already technically fit and can sit in an OSV world and do interesting things. Well, if unikernels are more than just individual projects, what about an ecosystem, right? I mean, you know, you need to have an ecosystem building around these things, and there's actually a lot of stuff going on. We're just going to look at a few of these ones. You know, Jitsu, Minios, the rump kernels, and Xen Project itself. Jitsu, just-in-time summoning of unikernels. Basically, it's a DNS server that looks to see if there's some host out there that, or something out there that can generate something to respond to the request. If it can't, it hands it to another DNS server to say, do you have something that can respond to the request? And it will actually start up a unikernel VM to respond to whatever is coming in. Interesting concept. It can actually be used outside of the unikernel world, but its design is for exactly the unikernel issue. How do you launch something as the traffic comes in? Well, this is one of the things that's out there that actually responds to that. MiniOS or MiniOS is actually sort of a skeletal unikernel. It comes in the Xen Project sources. If you go out to the Xen Project source tree, you will find MiniOS. And it becomes sort of a template that you can then take and use as you will to build your own unikernel-based systems. In fact, the ClickOS people did exactly that. They started with MiniOS. And they developed the thing that they wanted to do for networking. You know, it's out there for you to hack away. And it's part of what Xen is doing to try to add to this environment. Rump kernels, how many people are out of the BSD camp here? If so, you may know more about rump kernels than I do, but they've got this any kernel architecture. And once again, rump kernels fits well within Xen, and we've got a couple engineers that have spent quite a bit of time to try to make sure that the rump kernels will continue to work well within the Xen area, as well as working in bare metal and user space stuff that already has been done in the BSD world. So kind of marrying into that as well. Now, Xen Project itself, in the past couple developer conferences, there have been a number of different things that have been presented about trying to facilitate this next generation of cloud. One that happened about a year ago was a redesign of event channels. And event channels have to do with the way data is passed around between the various elements. And until about a year and a half ago, you could only get maybe a couple hundred VMs because of the way event channels were designed. That went through an entire redesign, and now basically the theoretical cap is in the millions. So we basically removed the barrier. The NEC people, the ClickOS people at the last developer summit did some really interesting timings and benchmarks, and they said that they could get really strong performance up to about the 300 and something level of their VMs going out there. As they get past that, other factors start coming in that start bringing down performance. As a result, the platform team, which is the central team that deals with the Xen hypervisor, is now focusing. We've identified a number of areas that need attention. The target is to try to get it so that we can easily support 2,000 to 3,000 unikernel VMs per host sometime in the future. We want to remove the barrier, because if we can get up to these sorts of numbers, then basically your iron, your big, expensive, hot, sweaty, energy-sucking iron, can be used for those big, hot, sweaty tasks that require big iron. And maybe we can reduce the amount that some of these other tasks take up. Now, why else might Xen Project be useful for this? We have power virtualization. We have power virtualization, we have hardware virtualization, and we actually have two modes that are optimized in between, PVHVM and PVH, which is the new one. But power virtualization itself as a concept feeds this really, really well. Why? Because in a power virtualized world, which is something that Xen pioneered 12 years ago, this was before the time that Intel and the other manufacturers had virtualization support in the hardware. So hardware virtualization was not possible because the support wasn't there. So they said, okay, well, rather than trying to make everything look like a piece of hardware, there are lots of things that we could do if the guest operating system just had a pipe. Network data, throw it down the pipe. Wait for the response, grab it out of the pipe. No packing it up for some sort of, no packing it up for some sort of fictional hardware which isn't there. Just really efficient. Throw it down the pipe, wait for a response out of the pipe. And this is the way power virtualization works. The downside to power virtualization is that, number one, your guest has to know that it's power virtualized. So if you're using legacy operating systems from out of the northwest portion of this country, they're not going to know that paravirtualization is going on. So you need hardware virtualization for those folks. But if you have something that actually knows that can be told that it's got just a big old pipe to jam data in and out of, it can work efficiently. Now, in this particular case, when you're trying to deal with these teeny tiny unikernels, that means it doesn't need any fancy drivers. It doesn't have to know what a network card looks like. It doesn't have to know what any of these devices look like. It doesn't have to pack up data. It doesn't have to do anything complex. Just throw data in there, wait for the data to come back. Very simple, straightforward, lightweight, fast. So the PV support becomes a key and perhaps one of the central reasons why many unikernels start with Xen. Because if you're going to start small and light, we can do small and light. Now, there are other ones out there, too. And if you look at Arrakis and Clive, there's a few others, too. I just didn't want to keep adding list after list. But there's lots of stuff going on out there, lots of investigation, lots of people trying different things to understand it. It's exceptionally interesting, and there's a lot of work going on. Now, is this a panacea? Absolutely not. As I said, unikernels have their place, potentially, but other things have their place too. If you're running some sort of multi-terabyte database that needs some sort of gigantic engine, well, you still need to use your multi-terabyte database that uses a gigantic engine. Fine. Do whatever it is you got to do. But if you're running web servers, you're running network devices, you're running DNS servers, all these various services that are really not strenuous. Keep them light, keep them small. Give them the smallest footprint you can. And save the iron for the big stuff. So different problems require different solutions. You pick whether this works for you or not, and in what place it works for you. I believe that in the next few years, if we're at scale 18x, and we're talking about unikernels, we'll look at this stuff and say, man, was that the Dark Ages or what? Cavemen playing with their bones and sticks. That's what it looks like. And I think it's going to be true in the Docker camp too, quite honestly. I think that we're going to see these various concepts develop into some things that maybe we really can't imagine very well right now. I think we're on the cusp of something. But as we take all these various concepts of how do we make the next generation of cloud small and light, keep the impact low, keep it green, I think we're going to come up with some really exciting things. So this is the type of area that deserves attention from utilization, but also from developers. If this tickles your fancy as a developer, start looking, I mean, there's some interesting things there. You might be the next one to come along and say, hey, why don't we do this? If we're come this far, why not this new thing? I think it's that sort of glowing growth area. And I think it's going to bring what we consider clouds to new heights. Now, this, my friends, I'm putting on my open source advocate hat, which I've worn proudly for 20 years, is an example of how open source is a center of innovation. This is not copying someone's proprietary function. This only works because people like you put on your thinking caps and say, hey, we can do something different. We can do something better. We can try something we've never tried before. And we can work with other people who have those skills, whether or not they sit next to you at work or they're 4,000 miles away from you in the ocean and you'll never lay eyes on them physically. It's part of the terrific power of open source. And I believe very definitely and distinctly that likewise clouds, which I have seen change so drastically over the past 10 years, are going to be changing even more drastically in the next several. And all the more reason This should be something that should be facilitated by open source, because that's where all the brain power is coming. That's where all the invention is coming. And it's following through with this. And as I say down here, friends don't let friends go closed source in the cloud. You know, I do a lot of these conferences. I see a lot of people, some of whom are with particular proprietary vendors of hypervisor technology and cloud technology, that said, you know, when we started, it gave us what we wanted. The price tag wasn't too bad. It worked. And now I turn around, I'm doing so much of it that I just hear this powerful sucking sound coming out of my wallet every time the bill comes in, and it's like, my God, what are we going to do? And I will give one of my Xen talks talking about, you know, what we have inside the latest release, et cetera, et cetera. And for people who don't know, we just had our 4.5 release last month. We had the most number of new features in any release in a decade. We're not just doing speeds and feeds here. We're trying to do new stuff. We're trying to break new ground. And when they start hearing about what we can do, and all they have to do is yum or apt-get and reboot and go on, it's like, why am I paying this money? And I say, where are you? And I can talk to you about that, you know. So, sir, did you have a comment? Yeah, just when you thought Xen was going out of style, which is an interesting thing in and of itself. And I didn't even have to pay him for that lead-in. We can send you a shirt. I contend that clouds are too critical to leave to hypervisors that aren't innovating. And you can take that for whatever you're working with. You know, if we're just focused on yesterday's payloads, you're going to get yesterday's results. We need to be working forward. One of the things I can say very proudly with Xen, and for people, how many people worked with Xen sometime in the past? How many people worked with Xen sometime in the past and got frustrated over something? Yeah, okay. There's a reason for that. Because sometime in the past, Xen went through some major changes. It had been, you know, it's been open source for 12 years. There was a private company, as normally often happens in the open source world, which built around it so they could do their extra, you know, added value sort of stuff, make some money, fine. Then that got sold to Citrix, and some level of dysfunction began to occur. And Citrix wasn't really sure what to do with the open source world. The open source people were sort of being a little headless at the time. A lot of the major players went off and founded a new company. So for a while, we were not playing well with others. How many people remember the Xen kernel? Whenever you had to use Xen, you had to go fishing around somewhere to find the Xen kernel. And the Xen kernel was because there were patches that needed to be sent into Xen, or into the kernel, into Linux kernel, and accepted, that weren't getting there. Well, about 3 years ago, there was actually about 3.5 years ago now, there was a big change. And dealing with the upstreams and downstreams properly became a priority within the project. Right now, if you go to kernel.org, you pull down a kernel, it has everything in that kernel that you need to run Xen. All you need is some utilities to go with it. Bingo, bango, get to work. That was, you know, part of an old sin that we were dealing with. Likewise, QEMU, we had our own version of QEMU. Not that we used the virtualization QEMU, but we used device modeling. Because QEMU does a bang-up job modeling devices, and there's no sense rolling your own. But once again, we weren't sending in the patches and getting them into QEMU. Our error, our mistake. Right now, the currently shipping 4.5 by default goes with the stock QEMU. You still have the option of using the one that we patched if you want to. We provide it, but might as well go with the stock one. We've learned from our mistakes, and in doing so, a lot of this notion of, you know, Xen being passé, we think is bunk at this point. A lot of the, there was a paper, or at least not a paper, but an article that was written by someone from SoftLayer that I became aware of about a week ago, which they deal with, anyone here from SoftLayer, by the way? I don't think so. They have products or services that deal with Xen and KVM and Hyper-V, and this man did a comparison of the three. And he said, basically, if I need something to scale and work fast, I use Xen. Xen has more options inside some ways, so some of these things, well, it's PV and HV and power virtualized when hardware virtualized is better. Well, we do have hardware virtualization, and we have optimized hardware virtualization. You have to turn it on. It literally takes one line of the command file. Start your VM, bingo, there you go. So, I mean, there's stuff out there that a lot of people don't know that's there yet because they got turned off long ago because we blew it. But we are working to make sure that we don't blow it again. And so we are busy trying to move the cloud forward. And if you're working with someone who isn't, I suggest you encourage them to do so. We have to. This has got to move forward. Open source has got to be the center of the cloud, period. I believe it is already, but let's shout it loud and long. Let there be no doubt. This is stuff that we do as a community. There's my email, my Twitter. This is already up on the presentations and video sections of xenproject.org, which if you've never been to, it's basically just about anything that we have that takes either a slide deck or that's been recorded goes out there. You literally have hundreds of hours of information that you can get any time you want. We're open source, we don't charge, we don't care about that sort of stuff. We're trying to make it available to you. Questions? Sir?
So you said earlier that microkernels require a hypervisor, and then you mentioned rump kernel, which says you said could run on bare metal. So what are the capabilities or features of the hypervisor that the microkernel requires that runs everywhere there?
I don't know much about rump kernels. Let me just say that flat off. I put it in there because I know that we've had a lot of people working with it. But the hypervisor layer at least gives exposure to certain basic I/O, stuff like this, where network traffic in, out, device sort of things in and out. Because we can do it power virtualized, we can keep it very clean, very light. How the rump kernel people do what they do, I don't know. But NetBSD, from what I've worked with NetBSD in the past, they are really, really good about keeping things small. It goes part of what their charter is, I think. But as a result, I don't know how wide their hardware list looks to be and how that plays out in the rump kernel world. Unfortunately, I don't really have much more I can say on the subject. However, if you want, give me information. I can chase down one of the engineers over in Europe that's actually worked with them quite a bit. We do have a few engineers who are active inside the BSD world because we see, Xen, we've had NetBSD support for Xen for a while. We just got domain 0 support back in FreeBSD, as well as the fact that we've had that for guest capabilities for a while. We want to play well. We want to play well with our neighbors and be a part of as many things as we can well be a part of. But I'm afraid I just don't know enough about the whole rump kernel world. I'm sorry.
How much of what you were saying applies to Xen running on ARM? And also when you're talking about 300 or 1,000 simultaneous images going at once without degradation, what kind of access to I/O and network are you talking about?
Inside the particular, let me answer the second one first. For the 300 number, it was particularly having to do with the ClickOS people. And ClickOS is basically virtualized network devices. So, you can imagine the list. But basically, they wanted to be able to do, you know, packets in and out for switches and other, you know, routing sort of situations. And that was the sort of measure that they were dealing with. And on their website, they may give better detail. Honestly, I don't know all the ins and outs. Yeah. And what they did is they basically kept zapping workload higher and higher, and then they watched the performance as the number grew. And what they found is that up until the 300 and somethings, they were getting, you know, good blistering responses. But when it got up into the 300s and plus, things started to level off, and they weren't getting the total throughput that they needed. That basically there were resource constraints going on as these things were being generated that was choking them out. And those were, as a result, those numbers were taken by the platform team to say, what can we do to get rid of these thresholds? What can we do to make sure that the performance keeps going up into the thousands? And so there's been a lot of work in that area. There continues to be work in that area to, you know, with that target in mind. You know, it's still being engaged, but it's en route. It's the type of thing that no one's throwing up their hands and saying we can't do this or we shouldn't do this. It's like, okay, well, we're just going to find our way through this. And if they have to redesign certain structures to make them more efficient, then that's what we're going to do. You know, remember that inside the hypervisor world, up until 5 years ago, as I said, if you got up into double digits of VMs on a host, you were feeling pretty good about yourself for the most part. Xen on ARM. Now, Xen on ARM is one of those things that it's actually working pretty well. We're still doing a lot of development in that area. For how many people are looking at ARM inside any way, shape, or form, just as an architecture? Okay. There is, if you go to our presentation section and look at one of the overview presentations, there's several sections that deal with some of the ARM stuff. One of the things that's absolutely exciting is that, in fact, when the engineer who was working with it, Stefano Stabolini, was talking to me about it, you could see him just getting absolutely excited. He said, the ARM hypervisor extensions look like they were written for us. And so you have, you know, a kernel mode, you have a hypervisor mode, you have a user mode. And he said, it fits. We never have to change mode. Xen on ARM stays in the hypervisor mode, period, end of discussion. So you never have to worry about losing control of something when elevated privilege is there, because there isn't elevated privilege. You're staying in hypervisor mode, period. And what's more, the structures that we expect architecturally fit. The user structures fit in user mode. The hypervisor structures fit in the hypervisor mode. Excuse me? I don't know whether the individual unikernels have been tried on ARM. I think OpenMirage may have already been built there. I'm not sure. I would go to their website to take a look, or, you know, just ask them, frankly. But I mean, some of these things I know that's definitely a target for them. I just don't know how far along they've gotten on these things. But yeah, I mean, it's a story that can work. And of course, the whole ARM story is one of lower power and so forth. So it becomes a natural fit to look at unikernels in that world. And so I know the work is there. I just don't know how mature it is, quite honestly. Sir?
So you mentioned that Xen is a layer 1 hypervisor.
Type 1, yeah.
Does that mean you have two ways of running it? One you can run on top of a Linux kernel, and one you can run directly on hardware?
The Xen runs directly on hardware, period, end of story. If you're using a Type 2 or Type 2-ish, there's always debates about what's a Type 1 and Type 2. Something like KVM, for instance, KVM works within the Linux kernel as sort of the software host to it. So it needs the Linux kernel to be there to exist. That's a different architecture than what ours is. Which is better? Whichever one works best for you. We think that in the unikernel world, the fact that managing these thousands of discrete small VMs becomes a very nice fit for a Type 1, because we don't have to worry about whether or not a host operating system is tuned for that sort of performance. Linux as an operating system has other goals, and so it may work, it may not work, or may not be as good as it could be, et cetera. So the only thing that we have the concept of what is called a control domain or domain zero, DOM zero sometimes for short, and what that is a VM, and it is just a VM that has the privilege to talk to the hypervisor. Something's got to tell the hypervisor what to do. So its function number one is to talk to the hypervisor, tell it to start up, shut down various VMs, whatever. Second thing that it does is the question of drivers. How many people remember the days 15 plus years ago, if you were working with Linux, you go into your computer store, you went to maybe your weekend computer show, you came back with that wonderful piece of hardware that you were drooling about, you put it in the machine, only to find no driver. So then you start searching around, you try to see whether a new release of the operating system has it. You go out to Freshmeat or SourceForge, you're trying to find a driver, you got to get it compiled and put in, blah, blah, blah. Even if, well, the people who did the initial Xen design said, you know what? Why do that? Why not leverage the fact that Linux and the BSDs already do a pretty good job of getting on top of new hardware? So whatever's used in domain zero, we will leverage their drivers to talk to the hardware. So that's the only function in which things arguably can go through the operating system just to touch the driver.
That's what I was getting at. So you have one more question. So you have this big monolithic binary, and I want to run it on the unikernel. Are we kind of targeting workloads that don't do a lot of system calls, or are you trying to something that mostly do most of this work? Is that kind of what unikernels are like?
Well, I think unikernels are, that would probably be a fallout of it. I would think. Some changing the lighting in here. Is that a hint? Yeah, that is a wrap it up. But I don't think that's directly the design, but I think it's sort of the sort of natural outgrowth that you're looking for, the things that can be small light processes, ideally. Because taking PostgreSQL and putting it in unikernel, why? I'm not sure what you get out of that other than, arguably maybe some a little bit better security, but really that's kind of it doesn't sound like a good trade-off to me. And I think it would be problematic inside some ways. So it's like, what can be done that's small and light? And the thing is, in your average data center, there's a lot of stuff that's being occupied by things that are really not heavy lifting. So we want to make them as small as we can, as light as we can, as green as we can, and then if we're going to have big iron, we save that for the big fat tasks that require big iron.
Early on, you said that the environment that the guest runs in just what it needs to operate.
Yeah.
And that may cause problems when it comes time to debug.
Mm.
What is the best practice for debugging guest on unikernel?
It's basically the same model that you use for embedded, which is you may be able to get certain data, depending on how you engineered that end product, but in a lot of ways you've got to spend more time with your development and testing to try to replicate things, because that's where you're going to have the more extensive tools. The embedded world has to deal with this all the time, quite honestly. I mean, if the infotainment system in your car, something fails, they're not hooking up a meter to it, except maybe to get some.
You actually have to build something that supports the debugging into the chip, because the external stuff couldn't keep up.
Yeah.
I think that some of that hardware is actually used for this.
So it's a question of how you want to do the engineering. Does it make it more challenging, yeah. But then again, once again, if you're focusing on things that are actually fairly light processes, probably worth the trade-off. At least a lot of these people are finding that, because like you don't normally spend a lot of time, I guess, doing core dumps on your switches either, you know. So I mean, we're trying to look for the best wins we can find, at least now.
Like debugging a kernel is just as hard as debugging embedded.
Yeah. This man said debugging a kernel is just as hard as debugging embedded. And that's kind of what we're dealing with here. Yeah, it's taking it up a notch, or down a notch, depending on how you want to look at it. We've hit the end. I will gladly take questions in the back, but I want to make sure that the next speaker has time to set up. Thank you very much for sticking with me.